talk is called Going with the Flow. I'll explain the title in a bit. I'm Gabriel. I'm a backend here at Mindera. So I'm going to explain what this talk is about, explain why I'm doing it and why I think this technology is relevant. And then I'm going to show you some simple examples and then some not so simple and then a harder example. So what am I talking about? When I talk about flows, I mean it's a new Java 9 API, but it's not new. So it is based on the reactive stream standard. And basically, it's the standard for reactive programming on the JVM. So does anyone know what reactive programming is? No? No one? OK. So basically, it's a mix of the iterator and observer pattern. Does anyone know what the iterator pattern is? OK, so you have a bunch of objects, or a list of objects, or a stream of objects, anything, and you can query for objects. You can ask if there are any more objects. You can ask for the next object, and so on. And the observer pattern, anyone knows what it is? OK, so it's the other way around. Instead of asking for items, you're pushed items onto you. And flow is a mix. So it's a mix of iterator and observer. So instead of only pulling or only pushing, you can pull and push items. So you can request and push items. And this is the Flow API. It's just 4 interfaces that you can extend. And this is the only thing you have in Java 9. This is just it. You have a class called Flow that has all these inner interfaces. And the only one that is implemented is Publisher. But the Java 9 implementation is a bit hard to understand. So it's a bit complex. I'm going to show you some more simple examples. So why is this relevant? Just these 4 interfaces. Basically, this is putting the reactive stream standards inside the JVM. So it is making it official, and this is future-proofing Java for reactive programming. So what this will allow in the future, or with these implementations that we can already use, is simpler code, more readable code, once you get to know it, of course. You can abstract low-level threading, synchronization, all that stuff. So you can focus more on business logic. It is more memory efficient because you don't have to load every item that you're processing onto the memory. And it is a bit one-size-fits-all. That's in quotes because, of course, nothing fits everything. So this won't solve all your problems, but it's a pretty good tool to have to solve a lot of problems. So now, this was just a quick introduction, so I can show you a bit what I'm talking about. So if you enter the Flow class, you have a lot of hidden comments, but this is basically just it. So you have a publisher. So this is what will give you your items that will have access to a subscription. So the subscription can request items from the publisher, and the publisher will call the subscriber. So it will push items onto your subscriber, that's basically you. So if you have no control over your publisher, you will just tell it what you want to do with each item, what you want to do when an error occurs, and what you want to do when it is finished. So a very simple subscriber, basically, is once you subscribe to a publisher, it will call unsubscribe, the first method. So what you want to do here is just with your subscription. So first you want to store it because it will be useful later on. So this is not how you code. So you will. Can you all read? OK. And you store your subscription. and then you can just start requesting for the first item. And then on next, so this is a really basic example, so we're just gonna print every item we receive. And then ask for another one. And then there's not much to do here because, again, this is a very simple example. And when it's done, we can just say that it is done. So with this doesn't do anything, basically. So you will just print every item, but it's a pretty good example of what you can accomplish with it. So if I can find my tests. Yeah, so here we have a test. Basically, we can use the already implemented publisher from the Java 9. And with this publisher, we will create my simple subscriber. I will subscribe to the publisher with it. And then I will publish all these items on the publisher and close it. And as I close, so whenever I submit here, my publisher will call on next on my simple subscriber. So I don't have to wait for this, so I can just execute and it will print everything. I had to add this here because the submission publisher from Java 9 is asynchronous. So we have to wait a bit for the threads to start. So the test would finish without printing. But basically this is it. So it's pretty straightforward. But if we go again to the Flow API, besides publisher, subscribers, and subscriptions, we have a processor. This extends both the subscriber and the publisher. What this is so we can chain multiple processors to apply changes to our items before finishing the subscription. So if I go back to my simple subscriber, I already have a simple processor. Basically, this is a map, a simple map. If anyone use functional programming or the Streams API, basically this will just apply a transformation to any item. So instead of writing a for loop to multiply each item by 2, I can just create here this simple transformer that will receive a function, and I can just tell it this function will multiply every item by 2. So if I get here, this is just for it to work. I think this is enough. So everything is the same, but here on next we can apply the function. So we call function on our item, and then we can call submit. Submit is a processor, publisher method. So this is what you use to publish items. And because this is a processor, it implements both a publisher and a subscriber. So you can subscribe from a publisher, but you can also publish to your subscribers. And I think this will make a bit more sense in a bit. So it's better if you call it result. It's a bit simpler. And then this is what the onError method is for. So if an exception is thrown by our method, we can just call onError and let it handle for us. And basically we will just print the stack trace. And then we can just ask for another item. what this will do, if I uncomment this, is create, so this is another filter processor that I will show in a bit. So we can create a publisher, we can also create a transform processor and a simple subscriber just like before. But if we subscribe with the processor to apply that transformation, and then we subscribe to that filter, this is the filter processor, so with the transform processor, so it is just a chain of subscriptions that will apply all these transformations to our items. And if I show you the filter processor, it will be the same thing as this, but with a predicate. These are all Java 8 classes, predicate function for functional programming. And so if I predicate, and we can just copy this and just change this to test. So basically a predicate will apply a function that must return always a boolean, so we can just check if this is true or not. So this will be a boolean, and here we want to filter results. So if the predicate is false, this won't make sense, so we can just ignore it. We can submit our result, no, not the result, but the item, and then we can print when it isn't. Okay, so now the test works, and if I execute it, basically we're going to check, we're going to filter all the X's in the list, and then we're going to apply this method here, so we're going to parse every int from the list, and basically we will be left with a subscriber of integers, and then we will just print all of these, and we filtered all the X's, and it's just missing a break line. So this by itself is completely worthless, and we will never use this the way I am using it, and it pretty much doesn't make any sense because this isn't any simpler to read, and it's a lot more complex. So to show you some examples that aren't so simple, I already have implemented here in the not so simple package some new subscribers. So I can create a subscriber and tell it what to do on each item and when an error occurs. So printing every item doesn't do much. So we can just tell it here what to do. I created a range publisher. So basically what this does is you tell it a range of integers, and it will just start publishing them, so we don't have to create a list and publish each item by hand. So when you go to the tests and you go to the not so simple tests, basically this is what it looks now. So it's a bit less verbose, but we still have to create each stuff, and we tell it here. So when we create our processor, now we can tell it what to do with every item, and we can tell it to do when an error occurs. And then when it finishes, we tell it to basically print every item. And that's what it will do. No. Okay, so this is for the map, basically. And for the range publisher, now this is even smaller. I just tell it to publish between 0 and 10, and this will publish every item between 0 and 10, 10 not included. So basically, I just tell it here to my publisher to print every item. So this is not hidden inside the subscriber. It's a lot more clear, and you can clearly understand by reading it what it will do. And then the same with the filter. We create a filter processor, and that we want to apply to each item that is greater to every item, and we want to filter all the items that are greater than 2, smaller than 2, actually. And this basically will do the same as the one before, but print just the ones bigger than 2. But this is still a bit too much. We still have to create a filter processor, and the filter method is hidden away here. So this is still not good, so we'll never use this anywhere. So now for a closer to reality example. So basically here, so the reactive stream standards already existed before this Flow API. So there was a library called Reactive Streams that is just the Flow API. So the Flow API just copied the Reactive Streams library and put it inside the JDK. So if I come here, this is the Reactive Streams repository that had here, it has these two models called examples and TCK. TCK is a technology compatibility kit because when you implement this API, you have to follow a standard. So this is just a bunch of tests that you can use to see if your implementation is according to standard. So I just removed every mention to the Reactive Streams API. I changed it with the Flow API from Java 9, and it all still works. And if I run the tests and I build the repo, this will take a bit because there are a lot of tests. But basically, I hope it doesn't have to connect to the internet. And yeah, so the tests pass. So the Flow API is compatible with the standard. And this is to show you that there is already a very, very big implementation of the Reactive Stream standards called RX Java, so it's Reactive Java. And I did exactly the same with this. So I changed all mentions of Reactive Streams to use the Flow API, and it will do exactly the same. If I run the tests here, again, I hope it doesn't have to connect to the internet. And we can see here that all the tests passed. And here, this one takes a bit longer because there are a lot more tests. But I don't know if any of you already used any reactive library, but it is a lot more complex to implement, but it is all fluent. So you can just chain operators and you don't have to create objects like I did in my tests, like this. So it's a lot more fluent and a lot closer to this. So if I show you here this publisher, so I implemented a publisher, and this is just a single method that I have to implement. And I added some simple stuff like subscribe actual, because I want to flow, so I want this to be fluent and chain subscriptions. So basically, like we've seen before, this will all just be a sequence of subscriptions, and I need to know what came before to subscribe. So this is what will be called every subscribe to subscribe to the upstream publisher. And then when you subscribe, you can tell what you will do. So this is like the end method. You tell it what to do with each item. And then there's a creation method. So the range is already inside the publisher. And then you can just call map and filter, and you don't have to create transformers. And the way this works here, so I can show the range first. Basically, this implements my publisher. It's an abstract class, so it extends it and implements it. And it will implement its own subscription that basically, with some care here for synchronization with an atomic, it just creates, so it will submit every item inside that range to all following subscriptions. So this one is pretty simple, but if I go to a map, basically the map will be its own publisher again, so it will extend the publisher, and it will keep a reference to its upstream publisher so that it can subscribe to it. And so instead of doing like we did here and just subscribing and then subscribing again and then subscribing again, here in this test we can see that we can create a publisher that will emit items from 0 to 10, multiply every item by 2, filter every item that is bigger than 4, and then for every item print it. When it throws an error, print it, and when it's done, print it, because there's not much we can do here. Basically, this is what it will do. So here it will be a lot more clear. And here we can see that map will catch the exception, so this won't break my test. It will just enter here on this callback and just print O, so it would only fail if it actually emitted any item. And this is a lot closer to the reactive Java implementation. I don't have, I think, yeah, so it's the same. As you can see. Basically, that's it. And then you can call subscribe. And just like below, you can fail the test, you can throw an exception. So when I said this is not so closer to reality examples, because the standard dictates that this must be asynchronous. So I didn't use any threads or anything asynchronous, but this one actually does. And basically that's it. And basically there is absolutely no need to do anything I've just done in this talk, because it is all already done in the reactive Java library. It's just so to talk a bit about the Flow API, so that you know that reactive programming is in the future of Java, and along with it, functional programming like we've seen. That's it. If anyone has any questions. Well, one question, okay.
Do you think one of the goals of adding this to Java was to incentivize people to create new frameworks that implement the same spec, or?
Also, yeah. It's also to make it a bit more official, so to show support to the standard, but also to incentivize people. Just having the interface without any implementation shows people that they can just do whatever they want with it. Well, that's it. No more questions. Thank you.